Okay, welcome to the discussion for section 4.2. We've got a couple of questions asked, so we'll take a look at those. 4.2 is solving a 2x2 system using substitution. Excuse me. So I was asked to look at number 7. And for most of the problems up to this point, there's an easy substitution to make. There's a quick and easy x or a y that you can just move the other term to the other side and quickly have, x equals this or y equals that. And in this case, it's just one extra step, but it's not terribly difficult. The first equation is 6x plus 3y equals 12. And then 2x plus 5y equals also 12. But this top equation, everything is divisible by 3, right? If I take this top equation, divide the left side by 3, divide the right side by 3, that gives me an equivalent system, which I'll just write here. 6 divided by 3 is 2, so I have 2x plus y equals 4. And that y is easy pickings, right? It's easy to isolate this. And so my equivalent, system is this. Right? If I just subtract 2x from both sides on this equation, that gives me y equals negative 2x plus 4. And that I will replace into the y for the other equation. This gives me, and I will probably need to move up here in a moment, but that gives me 2x plus 5 multiplied by the equivalent expression of negative 2x plus 4 equals 12. I'll take this 5 and distribute it through, but I'm going to go ahead and move this up to the top. So if you need this, pause it now. Here it goes. Distributing this 5 gives me 2x minus 10x plus 20 equals 12 still. And now it's just an equation in one variables. Sorry, kind of leaving the screen here, I'll try to keep it in. But if I combine the x terms, I've got negative 8x plus 20 equals 12. If I subtract my 20 from both sides, I have negative 8x equals negative 8. And dividing each side by negative 8 gives me x equals 1. Now I know that x equals 1, I can take this x equals 1 and plug it into any of the other equations, right? The one that I had divided by 3 to get was probably the easiest. That ended up being 2x plus y equals 4. And in fact, I subtracted that 2x to give me y equals negative 2x plus 4. I can take this x equals 1 and plug it right into there, and it's a quick, easy solve. So y equals negative 2 times 1 plus 4. That's negative 2 plus 4, so y equals 2. And that's my solution. X is 1, y is 2. Good. All right, the other one that I was asked to look at was number 9. Number 9, a lot of what we do is to make life simpler and avoid fractions, and you cannot really do that here. They're right there from the get-go, right? But my system is y equals 5/4 x plus 3/4, and y equals negative 2/3 x minus 38/3. Okay. So it's pretty easy to say, well, I've already got a y isolated here, so I can take this y equals all of this expression and replace the other y, right? So it's really just the right-hand side of this equals the right-hand side of this, right? So I'm going to write this here. I'm going to say that this equals this 5/4 x plus 3/4. Right? And that's really what I want to solve. I'm going to erase a lot of this because we're going to need the space anyway. So this is what I want to solve. The right-hand side of one equation is equal to the right-hand side of the other equation. But I've got all these fractions. So what do? Well, I look for the lowest common multiple, and that is 12. So I'll multiply everything by 12. Well, the 12 cancels with the 3, that leaves a 4, so I have negative 8x. I'm going to write it up here because I want the room later. Minus, well, the 12 here cancels with the 3, leaving a 4 again. So I have 120 plus 32, so 152. I'm going to double check that one because, you know, I'd hate to be wrong. Oh, I'm right, okay. Equals, the 12 cancels here, leaving me with a 3, so that's 15x. And 12 and 4, that leaves me with a 3 as well, so plus 9. Did I leave the screen again? I did. I'm not doing great today. Equals 15x plus 9. Am I back on? All right. Okay. So I'm going to erase this one here, and I'll work this problem, right? I want my x's on the same side, so I'll probably add 8x to get them to the right-hand side to keep my x terms positive. And I'm going to subtract 9 from both sides. The 9 is out of the right, the x's are out of the left, right? This gives me negative 161. Excuse me. Negative 161 equals 23x. Hopefully negative 161 is divisible by 23. Otherwise, this problem is just terrible. Well, let's see. It might not be, I don't know. It is 7. Very nice. So it's negative, and x is negative 7. Okay. Now I can take this and put it into one of the original equations. They're both terrible because one has a denominator of a 4, the other one has a denominator of a 3. Neither of those is going to cancel with a 7. So I'm going to choose the first equation because I don't like the way that 38 over 3 looks, right? So I'm going to plug this into the second equation. That is y equals negative 2/3. X is negative 7. Oh, I chose the wrong one. Back that up. I want equation 1. Again, I'm choosing equation 1 simply because there's a 38 over 3 in the second one, and I don't like that. So I could do it, I just don't want to. So 5 over 4 times this negative 7, and then plus 3/4. So that is negative 35 over 4 plus 3 over 4. That's negative 32 over 4. 32 is divisible by 4, and we get negative 8. So x is negative 7, y is negative 8, right? We couldn't avoid the fractions because they were there from the get-go. But we can, when we get to 4.3, there is a way that we could have manipulated this to not have to deal with the fractions through the whole thing, but don't worry about that till the next section. Alright, thanks, and I will see you guys for the next one.